And ladies and gentlemen, welcome back to my channel, guys. Welcome back to my channel. Before the video starts, I have a good news for you. So I'm gonna try to do some diversity of videos. So I'm gonna try to combine experimental, practical. So practical is where I'm gonna teach you some theories, some concept about stuff. And also for the practical, we're gonna have a lot of design to do. We're gonna have a lot of calculation to do, some exercising to do. So we're gonna have a plenty of video coming up. So if you don't want to miss this opportunity of learning for free, so join the community, sharing this video, liking this video, and also the most important part is to subscribe to the channel, guys. Subscribe to the channel, guys, and share the video to your loved one, to someone in the video, right? Someone needs this video. Share the video, guys. Don't be shy, guys. Without your support, without your interaction, without your help, I can make the video any longer, right? So I need your help, guys. All right, so let's just start. As I said before, we're gonna talk about something more important, experimental. We're gonna compare the results that you can get from the experimental design and also for practical design. So practical, like simulation, I'm gonna take abacus. I'll use abacus. And also for the practical, for the experimental that I did in the lab, yes, reality. So we use a lot of material. We use the steel structure. This is H-beam. H-beam, you can say H-beam, right? And we have our fledge, the first fledge, the top fledge, this line here. We have the left one, the right fledge, and below here, below we have the borrow fledge, and here this line and this line, the web. Okay, so this is the thing that you have to understand. And also you have the supports. This is like a support, this first support here on this stiffener. Yes, stiffener. So this one should be the first support. This one should be the second support. This is pin, this roller, right? And this is where our uniform forces will be applied. So we're gonna see how much this beam can carry without collapsing, right? And here we're gonna be this is where we're gonna have a maximum. We're gonna have our maximum curve of this beam, right? Because our support is here, and then we reinforce it with stiffener, right, to absorb the shock. All right, so let's just start with abacus then. So this is abacus. As I told you, this is abacus. If you've never used abacus, don't get confused. I'm gonna explain for you also step by step. So if you don't get what I'm doing, so you have to make sure that you comment, you leave a comment, right, in the comment section. So we're gonna start with abacus, and if you go on your left part, we're gonna see the model database here, right? So we're gonna start with the model database. The first thing that you have to do, you have to define your model. You have to give a model a name. I said it already. I put the name abacus one, then I'm gonna just keep the way it was, abacus one. Abacus one. This is our first video of abacus. Congratulations. And I'm gonna click on OK. It won't change because it's existing already, so I won't do anything. I'm gonna dismiss it, right? And now the second part is to define the parts. And because our plan is to design our web and flash, right, of the complete beam, right? So we're gonna go on parts. I'm gonna click on parts, and then I'm gonna create a part, and my part should be into the modeling space should be 3D. It should be deformation, and also should be shell and exclusion. Okay, exclusion, and also the approximate size. I can just take 100, 1,200. Okay, and then I'm gonna click on continue. Let me just pick like 12,000. Okay. I'm gonna click on continue. It's a lot, so this is a lot. So let me remove 10 and then click on entering here. Okay, this is just the frame to define our frame. It's not important. Sorry, it's important. You have to, if it's important, it means that you have to, if you know the length of your beam, right? You have to multiply your length of your beam into 2, so it's gonna fit this this table, right? Right, this table. This is the meaning of the approximate resizing. Okay, so here now we can start designing. We can see on the module here, we go on parts. Our first model, we left one model abacus and parts. We don't have any parts yet. It's empty. All right, so now we have a lot of step that you can. Now we have a lot of tool that you can use to design the beam. We have a lot of things here going on. We have a circle, we have a triangle. All of this they're useful, right? But I'm gonna use connected line. I'm gonna create the line to connect it. Or if you want, you can create an isolated point and then defines the coordinates. But that is not important right now. That's going to be the future if you have a complex design. So I'm gonna go here, the first connected line. I'm gonna click on the middle. Let's say if you don't the middle, it's simple. So the middle of this design is when x and y axis are 0. Like if I click here, you can see x and y on top here. Check here on top. When it's equal to 0, right? It's in the middle. I'm gonna just click there, and I need one of these parts to be 90. I'm gonna take 90. I'm gonna take 90. Okay. So if it's hard for you to pick 90, we can just go on x direction. Just click 90, and then in what direction click 0. Right? You can see this is here. This is x and y. So x starts with 90 and y starts with and y is the second axis, coordinate axis. So if you click on enter, you have your first flash. All right, so your first flash, and then here you can repeat the same. Click on escape, click here, and then I'll repeat the same. But here it's gonna be negative way. I took 90. I'm gonna take negative 90, and then y direction should be 0. And then I'm gonna click on OK. Now we have our left, this is our right flash, and this is gonna be our left flash, okay? And then here I'm gonna use the web. The web should be in the middle, right? It should be straight. And for the web, we have I don't have any specific dimension here. You can just create one dimension. I can modify it later. Let me just take. I'm gonna take 600. 600. So x direction is 0, and y direction it become negative 60. I mean 600. 600. Then I'm gonna click on enter, right? And here, if I zoom properly, I can go here, and our x should be 90. Do you remember? Our x should be 90, and y should be negative 60. Is the origin, right? 600. Click on OK, escape, and then come here and create another flash. Okay, it's gonna be positive. It's gonna be negative. Sorry, 90. Negative 90, and it should be negative 600. Okay, right? Now we have our beam, right? Now we have our beam. Right? So you can check we have the beam. But if you don't know if it's the correct dimension, right? We have two ways to check the dimension. First of all, you can change the dimension using the add dimension. If you click on add dimension, then click one dimension here, you can see 600, right? But if you want to modify it, click somewhere, then you can change it according to your work, right? To your beam. But I don't want to change anything. I'm gonna click on exit here. And also you can also check the auto dimension of this beam by going on these parts on the left side here. Go on auto dimension, click on auto dimension, and select the beam. And after selecting the beam, here, just click on enter. Enter. Then you will see all of the dimension that you create: 90, 90, 600, and 99, right? So they're symmetrical, right? There's nothing. And then here you can just go on X, and then you can confirm. You can confirm your you design by clicking on enter. Then the computer gonna ask you to give the depth of this beam, means the length of this beam, right? So we have a lot of options. Let me check my my length. I think it's just better for me to take 12,000. 12,000. So if I'm using meter, it's gonna be 12 meter. Okay, but it's a lot though. Um, let me take let me take 1.2. And then I'm gonna click on, I can change this later. Just click on OK. No, it's too small. It's too small. I will change the dimension. So from here, all right, from here I can just take let me take 1,000, 12,000. 12,000. Right, so it means like okay, it's better. And then I'm gonna click on OK. Now I have my beam. Okay, right, so this is the beam that I've been looking for a long time. So let me recapitulate for you first of all so you can understand. So if I zoom my beam, first of all, I wanna know the distance. This is the flange. This to a flange, top flange. This is the left part. This is the right part. So I wanna know the thick. I wanna know first of all the distance of the flange. So if you wanna navigate through this beam, we can go here on top under parts, like on top here, right? You're gonna see pan view. Just click on pan view, then you can be able to navigate through your beam, right? And I'm gonna click on escape. And if I go on tool and then go on query, and then here I can look for the dimension, general. I can go on distance. If I click on distance, I can check the distance of anything that I want. So I want to know the distance between this flag, the right flag to the center of the web. This is the web, right? As I said before. So I'm gonna click on this point and also this point and this point. You can see the distance is 90. Do you remember the number that I will put 90? You get there's a distance 90 and the component is negative 90, right? So I want to know if exactly the angle is perfect. Sorry. Let me do this first, okay? It doesn't matter. I didn't do anything. I just try to remove the go in previous option. So here I want to know the distance between the top flash to the bottom flash, right? So the distance, the height of the web, in other words. So I'm gonna click on the top, the bottom points here, and then the top here. I will note how much is 60. 600 point, let me do it again. We do it properly. One. So it should be 600. So 600. Do you remember the 600 that we put, the line that we design? This is the line that we design. And the 12,000 should be here. I'm gonna do this. I'm gonna use the pan to navigate through my beam. I can just use the mouse and then reduce the zoom out. I mean zoom out everything. Then I'm gonna go again and click on the pan. Then I'm gonna click on this middle point, and this middle point here, and it's 12 times 10 the power of 3. Okay, so this is our distance of this beam. So our point now, in the next video or in this video, we're gonna see, I don't want to make the video longer, so it's gonna be boring if you keep the video longer. So now we have our parts already. We have designed our parts, right? So now we have we need to define. The next time we have to define the material. I can define the material. If you want to define the material first, let me click here. If we're here, you can create, you can change here. You can go in properties, and under properties, wait a bit, you can define the material. You can create material. Just click on, right click on it, or click on it, the same. Then, then I'm gonna name material steel. We can modify anytime. I just show you according to your work, right? And here we can go in general, and then, but most of the time is about mechanical elasticity or plasticity. I'm gonna go on mechanical, and I'm gonna take plasticity, right? All of this is about the type of the steel that you're using, the yielding, the plastic strength, and also the stress of the steel, right? So, or here you can fill this information according to your projects, and I'm gonna go through it in the next video, so I don't want you to confuse about this. So next video is gonna come very soon, so make sure to join the community by sharing this video, by liking this video, and also by subscribing to my channel, guys. We have a lot of video to come, so if you don't wanna miss this opportunity, guys, it's it's so helpful for you, and also it's gonna help you to understand more about civil engineering and also architecture. So we'll talk about the mechanical, the material, the elasticity, and the plasticity in the next video. Okay, see you in the next one.